Good afternoon, student. In this lecture, we are going to study topic electrochemistry. Weightage for this topic is with compulsory for 5 marks and with option for 7 marks. First of all, what is meant by electrochemistry? Electro means electricity. Chemical reactions are carried out by using electricity, that is called as electrolysis. What is meant by electrochemistry? It is branch of chemistry which deals with study of interconversion of electrical energy and chemical energy. It is also concerned with resistance and conductance of electrolytic solutions. It is also concerned with design and operation of electrochemical cells. In 11th standard, we are already studied what is meant by redox reaction, concept of oxidation, concept of reduction. First of all, we revise some concept that is important in this topic. Redox reaction, because electrochemistry is related to redox reaction, because in all electrochemical cells, chemical reactions involved are redox reaction. First is what is meant by redox reaction. Reaction in which oxidation reaction and reduction reaction takes place simultaneously. That reaction is called as redox reaction. First, what is meant by oxidation? For example, here sodium metal, its electronic configuration, atomic number of sodium is 11, its electronic configuration is 2, 8, 1. If electron in last cell is lost by sodium, then it acquires one positive charge plus one electron. One electron is lost by sodium, therefore oxidation is loss of one or more electron by any species called as oxidation. Another example, calcium, if it is lost 2 electron, then it acquire calcium plus 2. That is, in first case 1 electron lost, second case 2 electrons are lost, and third example is aluminium. If it is lost 3 electron, then it acquire aluminium plus 3 charge. In these 3 example, 1 electron, 2 electron and 3 electrons are lost by sodium, calcium, aluminium respectively. Therefore, what is meant by oxidation? Oxidation is loss of one or more electron by any species called as oxidation. Then another definition is also there. We are already studied what is meant by oxidation number in 11th standard. What is meant by oxidation state? In first example, here sodium has 0 oxidation state. By loss of 1 electron, it having plus 1 oxidation state. That means oxidation state of sodium changes from plus 0 to plus 1. That means increases by 1 unit. Then in second case, calcium has 0 oxidation state. By loss of 2 electron, it having +2 oxidation state. Therefore, oxidation state of calcium changes from 0 to +2. In third case, aluminum has 0 oxidation state. Aluminum +3 having +3 oxidation state. Therefore, oxidation state of aluminum it changes from 0 to +3. In these three examples, oxidation state is increases in all example. Therefore, another definition of oxidation is increase in oxidation number of any species is called as oxidation. Then next concept is reduction. Exactly opposite to oxidation. Here one or more electron lost by sodium, calcium and aluminum. Exactly opposite to oxidation. Reduction is gain of one or more electron by any species is called as reduction. For example, copper +2 ions accept 2 electron to form copper metal. Second example, silver +ion accept 1 electron to form silver metal. And zinc +2 ions accept 2 electron to form zinc metal. In these three examples, electrons are accepted by ions. Therefore, it is called as reduction. Another definition of reduction in terms of oxidation state. Look at here. Copper +2 having +2 oxidation state, and by accepting 2 electron, copper having 0 oxidation state, that is oxidation state of copper +2 ions changes from +2 to 0. That means decreases, exactly opposite to oxidation. In second example, silver having +1 oxidation state, it changes to 0. +1 to 0. That means here also decrease in oxidation number of silver plus ions. In this case, zinc +2 having +2 oxidation state. By accepting 2 electron, it shows 0 oxidation state. That means zinc +2 ions changes its oxidation state from +2 to 0. That means decreases. In all these three examples, oxidation state of copper +2, silver plus and zinc +2 ions decreases. Therefore, reduction is also defined as decrease in oxidation state. It is also called as reduction. Then next is what is meant by redox reaction. All reactions occurs in electrochemical reactions are redox reactions. That means reaction in which oxidation reaction and reduction reaction takes place simultaneously. For example, cell reaction in Daniell cell. Reaction is zinc solid plus copper +2. It gives zinc +2 plus copper metal. This reaction is redox reaction. This reaction is redox reaction. That means in this reaction, both oxidation reaction and reduction reaction takes place simultaneously. Then how these two reactions takes place simultaneously? See here. Here oxidation state of zinc is 0. Oxidation state of copper +2 is +2. Oxidation state of zinc +2 is +2, and oxidation state of copper is 0. From oxidation state, we can easily determine which species undergoes oxidation and which species undergoes reduction. Here, oxidation number of zinc increases from 0 to +2. Oxidation state of zinc increases from 0 to +2, that means it undergoes oxidation. And by loss of how many electron? It having +2 charge, therefore it lost 2 electron. That 2 electrons which are accepted by copper +2 ions, here copper +2 ions changes its oxidation state from +2 to 0. That means oxidation state of copper +2 ions decreases, that means it undergoes reduction by accepting 2 electron. Then separately you have to write oxidation half reaction and reduction half reaction as: first, zinc undergoes oxidation by loss of 2 electron to form zinc +2 ions +2 electron. This is oxidation reaction. These 2 electrons are lost by zinc atom which are accepted by copper +2 ions to form copper metal, and this is reduction reaction. And by addition of these 2 reactions, that is oxidation half reaction and reduction half reaction, we get redox reaction. Here 2 electrons lost by zinc metal which are accepted by copper +2 ions, therefore total effect of electron is neutralized, therefore these 2 electrons get cancelled and remaining is zinc solid plus copper +2 ions. It gives zinc +2 ions plus copper solid, and this is redox reaction. This is redox reaction. In this way, redox reactions are very important in electrochemistry because in all electrolytic cells, reactions occurs which are redox reactions. Therefore, this point is important while studying electrochemistry. Then next point is electrolytes and non-electrolytes. First of all, what is meant by electrolytes? Electrolytes, in this word indicate there is a electrical energy or electricity is involved. Then what is meant by electrolytes? These are the substances which dissociates in aqueous solutions and conduct electricity, that is called as electrolytes. For example, HCl, in HCl if we add water, then it get dissociated into its ions, that are H+ ions and Cl- ion, and its aqueous solution conduct electricity. Second example, NaCl to form Na+ ion and Cl- ion. Therefore, solution of NaCl also conduct electricity, therefore it is example of electrolyte. Then all strong acids, bases, and all ionic salt are examples of electrolytes. For example, NaOH, KOH, H2SO4. What is the dissociation of H2SO4? To form 2 H plus ions plus SO4 minus 2 ion. These are the examples of electrolyte. All acids, bases, ionic salts are the example of electrolyte. What is meant by electrolyte? These are the substances which dissociates in aqueous solution and conduct electricity. Then non-electrolyte. Second is non-electrolyte. Exactly opposite to electrolytes. Non means no, does not conduct electricity. Therefore, non-electrolytes are substances which cannot dissociate in aqueous solution and does not conduct electricity, that are called as non-electrolytes. Examples of non-electrolytes are sugar solution, sugar, then urea solution, benzene are examples of non-electrolytes. Then depending on, in this topic we are only concerned with electrolytes. Depending on high or low conductivity, there are two types of electrolyte. First is strong electrolyte and second is weak electrolyte. First, strong electrolyte. Strong electrolyte. Electrolytes which are completely dissociated in aqueous solution are called as strong electrolyte. For example, all strong acids, strong bases and ionic salts are example of strong electrolyte. For example, strong acid HCl in aqueous solution, it dissociates in its ion H plus and Cl minus ion. Here dissociation is higher, therefore strong electrolytes are electrolytes which are completely dissociated in aqueous solution. Second example, strong base, that is NaOH. NaOH in aqueous solution to form Na plus ion and OH minus ion. Then ionic salt such as NaCl to form Na plus ion and Cl minus ion. These are the few examples of strong electrolytes. Then weak electrolyte. Weak electrolyte. These are the electrolytes which are partially dissociated in aqueous solution. For example, weak acid, acetic acid. Example, acetic acid is the weak acid which dissociates in aqueous solution partially to form acetate ion plus H plus ion. Second example, NH4OH, ammonium hydroxide is also weak base. NH4 plus OH minus. These two examples indicate that what is the difference between strong electrolyte and weak electrolyte. In strong electrolyte, dissociation is indicated by single-headed arrow, and in weak electrolyte, dissociation is indicated by double-headed arrow. It indicates that these are weak electrolyte, that means its dissociation is in very small amount. That means in our solution, if we take aqueous solution of acetic acid, then it contains three species. One is acetate ion, second is H+ ion, and third one is whole acetic acid molecule. That means here partial dissociation of acetic acid takes place. As compared to strong electrolyte, weak electrolyte having lower conductivity. Then text point, electrical conductance of solution. Electrical conductance of solution. We know that electrochemistry is also concerned with resistance, conductance of electrolytic solution. Then, according to Ohm's law, we know that Ohm's law, resistance is equal to V upon I. According to Ohm's law, resistance of a conductor is the potential difference divided by current. It is the Ohm's law. Here R is resistance. R is resistance. What is the SI unit of resistance is Ohm. V is potential difference. SI unit of potential difference is volt. Capital V denoted by. I is current in ampere. Unit of current is SI unit of current, ampere. Symbol is capital A. Therefore, what is the unit of resistance? R is equal to another unit of resistance. Unit of potential difference is volt divided by ampere. Therefore, R is equal to volt per ampere. This is the another unit of resistance. Then what is meant by electrical conductance? Next is electrical conductance. Electrical conductance is denoted by capital G. Electrical conductance is the reciprocal of resistance. That means G is equal to 1 upon R. Electrical conductance is the reciprocal of resistance. Then unit of electrical conductance, that means unit of G is equal to 1 upon R. We know that unit of resistance is Ohm. Therefore, it becomes equal to Ohm inverse. This is the unit of electrical conductance. Then SI unit of electrical conductance, that means G, is the Siemens. Capital yes. And what is the relation between Siemens and Ohm inverse? 1 Siemens is equal to 1 Ohm inverse. This is the relation between Siemens and Ohm inverse. The next point is relation between resistivity and conductivity. This point we will study in next lecture.